All right, so what we're going to do is let's look at the path of this, all right? So this is an object that's in motion, all right? So this is, when you think in terms of x comma y, right? Whoops. When you think in terms of x comma y, first of all, this is like the distance over time, right? So my x value represents the time. You guys should be writing this down. So this is time. And then the distance. And we'll talk about the difference between distance and displacement. For now, we're just going to focus on distance. Oh, I misspelled the word distance. Distant. Okay. So this position right here is at, let me change the color on that. This position right here, we'll do blue. This one right here is basically at 1 second, this has gone 40 meters. Okay? That's what that means. At 1 second, this object has traveled 40 meters. And then way up here, at 10 seconds, the object has traveled 180 meters. Okay? So up here, when we say the total distance over the total time, this is the average. Okay? That's the average velocity. And technically, we should say that velocity is displacement, not distance, but we'll unpack that in a second. So the actual graph itself travels this path. Oh, also, I should probably also point out that right here at 0, it's not marked, but at 0 seconds, it's traveled 0 meters. So if you think in terms of slope, right, remember that slope is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, right? And so if you do the math on that, your slope, which is actually the velocity, the average velocity, is going to be your y sub 2. So if we use these numbers, it'd be 180 minus 0 all over, and we use these numbers. So this would be like x sub 1, y sub 1. This would be, let me move my face out of the way. This would be like x sub 2, and this would be like y sub 2, okay? So then on the bottom here, I would just have 10 minus 0. Whoops. I'm not sure what happened there. So this would be 10 minus 0. So when you do all the math on that, you end up with 18 meters per second. So that's really what this is up here, right? That's what all that stuff means. Okay? So the average is kind of like from here. Well, let me make that a straight line. Oh, that's really bright. Okay? So that's like the average slope, right? But notice that it doesn't always do that. So let's talk about what's going on from point to point. So from here to here, it's kind of a straight line. So that would be a constant speed from here to here, it's still kind of a straight line. So that's a constant speed. From here to here, it's still a straight line. So through all of those, and it should be a straight line. Unfortunately, my hand isn't always straight. This is a constant speed or velocity. And you'll say, well, what's the difference? Well, it depends on if we're measuring distance or displacement. But that's constant, bless you. From here to here, and I should point out this is a positive slope. So it's moving in the positive direction. But from here to here, my slope, which is the velocity, is 0. So whatever this object is, it travels real fast, and at 3 seconds it stops. And it doesn't move again until 6 seconds. And then, if you notice, the slope is very consistent from here to here, okay? So that would be a constant speed or a constant velocity, depending on how you're measuring it, okay? That's also positive. Now, I got a quick question for you guys. What do you think a negative speed would mean? Yes? Yeah, you're going backwards. So however you measure it, if I'm going this way at a constant speed, and then all of a sudden I reverse and I go back this way, you'll have a negative slope or a negative velocity. You're going back, right? Because we're measuring the distance from some starting point. So to have a negative slope, you're going to go back towards the original distance, or you're going to go backwards, basically. Does anybody have any questions about that? Okay.